Hi everybody, welcome back. Today we're going to take a look at heat of vaporization. The equation is Q equals mHV. Make sure you're copying down all the samples, that you're taking notes, and you complete the sample at the end of the video and bring it to class on Wednesday. If at any time you find the presentation is moving too quickly, please pause or rewind this recording to catch up. Just to take a look at the definition of heat of vaporization, it's the amount of energy needed to vaporize a certain mass of liquid at its boiling point. BP is boiling point, CP is condensation point. Remember, those are the same temperature. And 1 atmosphere, that is going to be the liquid to gas or gas to liquid. You see in the diagram where you have your liquid becoming a gas. Over here, we have Q equals M times HV. The Q, as we've seen before, is going to be our heat, and that's going to be measured in joules. M is going to be the mass of the liquid, and that's going to be measured in grams. HV is heat of vaporization, and that's joules per gram. Notice there's no temperature value in this equation. That is because the temperature remains constant. It does not change. We're on the plateau part of the graph that we looked at with the heating curve. On the back of the reference table, you'll find the equation Q equals mHV. Tells you what each represents, and then you have here your HV is the heat of vaporization. However, there's no value for heat of vaporization on the back of the table. So you have to go to table B, which is on the front. On the front, you'll see heat of vaporization. Remember, this is only for water, and it gives you a value of 2260 joules per gram. So here's a question that we're going to look at. Calculate the number of joules of heat needed to change a 25-gram sample of water to steam at its boiling point. So here we have heat of vaporization. We have to remember that we're talking about boiling, condensing, or we're talking about water. It's 100 degrees Celsius. So the temperature is not going to be part of this equation. The equation equals Q equals mHV. Second step is putting down our givens. We're going to be looking for the heat, which is Q is going to be our X. M is the 25 grams. And then the HV, we got that from table B. That's the number that we got from the beginning that we looked at. It's 2,260 joules per gram. So once we have the givens, you know the next step would be substitution. So we substitute in those values. Notice the grams are going to cancel and you're left with joules. So you're going to multiply 25 times 2260 and you're going to end up with joules for your answer. So to solve, you end up with 56,500 joules. Now, sometimes you're going to be asked to convert that to kilojoules. If you're going from joules to kilojoules, you're going to divide by 1,000. Okay? So, we round off first. You have 57,000 joules. And then when we divide by 1,000, we end up with 57 kilojoules. And that will give us the correct number of significant figures. That's what SF stands for, significant figures. So here's your sample problem. You're going to bring it to class on Wednesday. Question is, if 5,000 joules is required to evaporate 36 grams of a liquid at constant temperature, what is the heat of vaporization of the liquid? Make sure you calculate the entire answer, show the work, and we'll see you then. Thanks.